in order to be evolutionarily interesting, then it needs to be something that we see as a change in the gene pool. And change in the gene pool would be. I mean, I can't put an actual number of generations on it, but it's not a proper Darwinian change if it's just. For example, there's evidence that starvation effects
Yes, I was going to ask about that next. Yes,
and these are, as it were, I mean, epigenetic effects are changes in as the embryo develops, changes in the expression of genes in different parts of the body. So in liver cells, certain genes are turned on. In kidney cells, other genes are turned on. Muscle cells, other genes are turned on. Those are epigenetic effects. Now, there is some evidence that those epigenetic changes can be inherited into the next generation and possibly the grandchild generation. That's not a proper gene pool change.
Yeah, I think Richard is right on that, but what we would need to do is to look at the effects after billions of years, and that's exactly what the Human Genome Project did in its Nature paper of 2001. Remember, I referred to figure 42 of that paper. You see there the evidence that those genomes were changed by moving great chunks around in the genome. Not time, I guess, to go through the detail of that,
yeah,
but
unfortunately not.
That's fairly clear evidence that it must have happened during evolutionary timescale.